This conference will now be recorded.
So, very good evening, students. Today we'll be concluding this chapter, communication systems. So, today's topic is space communication. So, in this lecture, we'll be learning ground wave, space wave, sky wave, etc. And we'll see how propagation of different types of waves happen. So, first of all, what is space communication? So, the term space communication refers to sending or transmitting the signal, receiving the signal, and processing of information through physical space as the communication medium. Physical space means mostly the Earth atmosphere. Okay, physical space means the Earth atmosphere. So, in this type of communications, information will be carried from one place to another by electromagnetic wave. Okay, information will be carried mostly by electromagnetic wave of high frequency. Okay, and as you know, electromagnetic wave has velocity of light in the free space. So in this free space, electromagnetic wave has velocity identical to the velocity of light. Okay, so information will be carried by electromagnetic wave. I have written here as EM wave. E means electro and M means magnetic, electromagnetic wave of high frequency, and it will travel with velocity 3 into 10 to the power 8 meter per second. As you know, the speed of light, it is c, denoted by c. Okay, and the space communication uses the frequency which lies between 10 to the power 4 hertz to 10 to the power 11 hertz. So this is a very wide range, and corresponding wavelength 1 millimeter, starting from 1 millimeter to 30 kilometer. This is the wavelength used in space communication. This is the range 1 millimeter to 30 kilometer. And then, as I said, Earth atmosphere assists the wave propagation. Earth atmosphere will help the waves to propagate. And see, all types of radio communication, then television communications, and satellite communications are actually examples of space communication, or these radio, television, satellite communication happens through space communication. All are coming under this space communications. Now there are different types of space communication, different types of space communications. So first one is the ground wave communication. So what is this ground wave communication? Okay, let me, before I talk about different types of space communication, I'll give you a simple analogy by which you will understand three types of communication. There are three types of space communication. One is ground wave communication, then you have space wave communication, and sky wave communication. Okay, so let me uh, give you an example. Suppose there are two persons. Okay, two persons, they are playing with the ball. Okay, with a ball, one person is throwing and another person is receiving from the other side. Okay, this person is receiving. Okay, so this play can happen, like this ball can be transmitted to this person. So this is person 1 and this is person 2. So the ball can be transmitted from one person 1 to person 2 by like 3 ways. One is you just you can just roll. Okay, roll on the ground, you can do that. You can roll on the ground, it will reach to this person, right, from person 1 to person 2. You can directly throw in a straight line so that you will get it. So first is rolling. You can roll on the ground, by which you can transmit this ball to the another person. Okay, then second thing is throwing directly throwing directly to the other person. Throwing directly in a straight line, as I have shown. So this is the first method which I am talking. This is the second method, throwing directly. Or otherwise, if they are playing indoor game, then they might be having a roof. So this person can just throw it to the roof, so that this is a roof, suppose roof, the ball will be getting reflected and go to this person. So there are three methods. One is rolling on the ground, another one is directly throw in a straight line so that it will reach to the second person. Another way is that if there is a roof, if they are playing indoor game, then there will be roof. He can just throw it to the roof. After hitting the roof, it will be reflected back to the person. So these are three ways. Similarly, so this is actually reflecting at a roof. So these are three methods by which these two persons can transmit the ball from one to another. Okay. Similarly, there are three types of communication space communications. One is along the ground, which is called ground wave, and then directly transmitting the signal in a straight line through intervening troposphere space. Okay, tropospheric space, that is called space wave. Okay, I'll just remove this part. So one is through the ground or on the ground, along the ground, so that is ground wave propagation. Then directly in a straight line through intervening tropospheric space, that is called space wave or tropospheric wave. And third one, as I said, reflecting method. That means the signal can be transmitted to the directly upward to the sky and followed by reflection from the ionosphere. From the ionosphere, it will be reflected back to the receiving antenna. Okay, there are two antenna we had discussed already. Antenna can transmit as well as it can receive also. So there are two types of antennas, and see, from transmitting antenna, the signal can be transmitted, and by receiving antenna or receiver antenna, signal can be received. So there are three methods I have told, that along the ground or on the surface of the ground, wave can propagate. That is called ground wave. But anyway, you can understand that this wave is actually, whatever wave I am talking about here, all are electromagnetic wave. They doesn't require any medium to propagate. But But if you need a direction to propagate, definite direction to propagate, suppose I have like this. If I have a surface like this, when on the ground the wave propagates, it follows. Actually, it follows the curvature of the earth, and by following the curvature of the earth, the wave propagates. Okay, and if suppose there is a receiver antenna over here, it will reach to the receiver antenna. So this is how I'm saying the ground wave. Okay, then directly in a straight line, so that is space wave, we'll discuss that, and also we'll discuss the sky wave, which actually will be transmitted directly to the sky, and from the ionosphere the signal will be reflected back to the receiving antenna. Okay, now we'll take up one by one and try to understand. So the ground wave propagation, how it propagates, and first of all, what happens during during this ground wave propagation. So radio wave, so it is an EM wave, a radio wave that can travel directly from one place to another by following the surface of the earth is called the ground wave. So surface of the earth is actually the guiding factor for this wave to propagate from one point to another. Suppose I have two antenna here. This is the transmitting antenna, this is the receiving antenna. So this is transmitter, this is receiver. So this is the earth surface, as you see. This is the earth surface. Okay, earth surface. So when the transmitting antenna or transmitter emits the wave, that wave will actually, and obviously you have to understand that this transmitting antenna or receiving antenna, these are very close to the earth surface. That means this earth, like this height is not very long. Okay, from the earth, not very long. Okay, they are actually very close to the earth surface. So generally radio communication is done through this ground wave. Let us see. So this transmitted wave will actually follow the curvature of the earth, as you see from here. This is how the wave will propagate from one antenna to another antenna. So a radio wave that can travel directly from one place to another by following the surface of the earth is called ground wave. And ground wave propagation is possible only when the transmitting and the receiving antenna are very close to the earth surface. So this is another important factor, okay, for ground wave propagation. Now this ground wave is actually guided by the earth and bends around. Actually, as I was showing you, suppose earth surface is something like this. It is not very smooth, so ground wave will just follow this pattern. Okay, this is the earth, and this is the propagation of the wave. Okay, so this will follow the earth surface, like wherever there are bends and all those things, it will follow. So a ground wave is guided by the earth and bends around the curvature because of the electrical, how it is, like why it follows, and what is the reason of following this uh, like how why this radio wave or the ground wave follow the curvature of the earth surface, because there is a electrical discontinuity between the atmosphere and the ground surface, earth surface. So there is a discontinuity. Okay, discontinuity between, because there is a discontinuity between the earth surface and the atmosphere, the ground wave will actually follow the curvature or various bends or curvatures of the earth surface. So during this earth surface, like when it is following the earth surface, what happens, like electromagnetic wave, it has electric field as well as magnetic field, and this electric field will actually induce charges on the earth. So when following the earth surface, okay, it will actually induce some charges on the earth surface, and as the wave travels, those charges also will travel, and that's how a current which is called surface current will be induced over the earth surface, right? So there will be a surface current, and this surface current will actually experience some hindrance or resistance due to the absorption by earth, and some cases there will be diffraction. So current or electromagnetic wave is actually electromagnetic wave undergoes diffraction and attenuation. Attenuation attenuation means absorption or loss of strength of the wave. So because of that, this ground wave actually becomes very weak if it is used for long distance transmission. So it is said that wave lies down and dies, lies down and dies, lies down and dies for long distance communication. So that's why long distance communication cannot be done with ground wave. Now we'll okay, so as I was discussing, there will be attenuation, okay, by diffraction or other effects, absorption by the earth, etc. And no, this is not suitable for long range propagation, as I was talking about. And the frequency range, see, frequency range possible, like information of frequency range 500 hertz to 1500 hertz is suitable for this ground wave propagation. And in terms of wavelengths which are actually greater than 200 meter are possible by this ground wave communication. So that's why this region of amplitude modulated band is called medium wave band. It is called medium wave band. Medium wave band. Medium wave band. Okay. So then what is the maximum range? What is the maximum range of wave propagation? What are the factors on which the maximum range of propagation depends on? So there are two factors on which, let me write first, factors on which long range ground wave, I'm writing GW, ground wave propagation depends on. So the factors are actually the frequency of the transmitted wave. One is frequency of transmitted wave. Why? Why this is a factor? Because as I said, EM wave will be attenuated by absorption, and EM wave gets absorbed or gets attenuated, I'll write attenuated. And attenuation depends on this attenuation of EM wave depends on frequency, depends on frequency. So if your EM wave has larger frequency, then the attenuation will be more, so the long range propagation will be less. Okay, so this is what it is. So frequency of the transmitted wave is a factor on which long range propagation depends on. And the second thing is the power of the transmitter. Power of the transmitter. Power of the transmitter. If the power is more, then long range propagation is possible. Now, to radiate signal with high frequency, the antenna should have a size comparable to the wavelength. I'll write this sentence because it is very, very important. To radiate signals of high frequency, antennas, this already we had discussed. Sorry, antenna antenna should have a comparable size comparable to the wavelength. That means how much? So length of antenna, at least it should be nearly this. So this is the least length or least size of the antenna should be in case of ground wave propagation. So antenna size has to be, I think this is common for everything. So if you want to radiate signals with high frequency, the antenna should have a size which is comparable to the wavelength, and the least is actually least size of the antenna should be lambda by 4. Okay, now we'll see some advantages and disadvantages of ground wave. So what are the advantages? So there are obviously certain advantages. Sorry, there will be certain advantages. Like here in the ground wave transmission, you need like transmitting power is enough. Okay, and it is communicated between any two locations on the earth. Actually, you can use this wave to transmit signals between any two. It helps to between any two locations on the earth surface. Okay, So it can be used. So ground wave can be used to transmit signals between any two locations on the earth surface. Then second thing is that the ground waves are relatively unaffected by the climate changing, okay, because they are on the earth surface. So ground waves are relatively unaffected unaffected by climate change, unaffected by changing of atmosphere condition, okay, by changing of atmospheric condition, but other two will be actually affected by atmospheric change, okay. Okay, so these are the advantages. Now we can find out some disadvantages as well. Let me write those disadvantages. So advantage was, the most important advantage was that the ground wave will not be that affected. That means it is relatively less affected by the change in the atmospheric condition. Okay, now what are the disadvantages? Actually, it needs high power transmitter. High power transmitter is required because otherwise long range propagation is not possible. It will be attenuated. Signal will be attenuated easily. So need a high power transmitter. Okay. Then second thing is that only low frequency, very low frequency and medium frequency signal can be transmitted. Okay. So since very low frequency, then low frequency and medium frequency signal signals are transmitted, it requires very long antenna. Requires it 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 requires large antenna. Okay, antenna. It requires large antenna. And another point is that the ground wave is actually guided by the earth surface. That means it is actually sliding over the earth surface. So that's why the ground loss vary with surface material and composition. Actually, loss is not a constant factor over here. Loss of the wave. So ground loss vary with surface material and composition. Surface material and composition. Okay, so these are the few disadvantages. Now we'll go to the other one, that is the space wave. So as I said, space wave is actually a direct method. Okay, directly the wave signal can be transmitted from one place to another. Okay, this is called tropospheric or line of sight propagation. So if a radio wave transmitted from one antenna, then traveling in a straight line directly and reaches to the receiving antenna is called a space wave. The space wave propagation is also called as tropospheric or line of sight propagation. Okay, now we learn uh, the range of space wave propagation is limited by. So you will learn few points over here. So the space wave range of sorry the range of space wave the range of space wave, I write SW for space wave propagation is limited limited by following factors. What are those? One factor is that the line of sight distance at which the transmitting and receiving antenna can see each other. So this is the line of sight distance. Since it is a direct transmission and direct receive like receiving process, so this is one antenna, this is another antenna, so they have to be actually directly facing each other. Okay, this is called line of this line is called line of sight. Okay, line of sight, so in short it is called loss, LOS, line of sight loss. So line of sight in short loss. So the range of space wave propagation is limited by line of sight distance. So what is line of sight distance? The distance at which the transmitting and receiving antennas can see each other. So the distance till which they can see each other. So that is called line of sight distance. Another factor is the curvature of the earth. Long range propagation is limited by. So range of space wave propagation is limited by two factors. One is the line of sight distance. That means till the distance the receiving and the transmitting antenna can see each other directly. So that distance is called line of sight distance. And then the second point is the curvature of the earth. Curvature of the earth. So the curvature of the earth. So these two factors are there. Okay, which limits the long range uh, or the range of propagation of space wave. Now we'll see this range actually depends. Okay, depends on the height of the antenna and on the radius of the earth. So we now will deduce expression for the distance up to which a TV signal, one kind of space wave signal, can directly be received by a TV tower of height h. So I have a TV tower which has height ht. Suppose this is the tower which is O here OA. I'm sorry. So this is a TV tower. Uh, Look, this is the height. Okay, this is the height h. This is on the earth surface. So this is the TV tower which has height h. and I can write this as HT. TV tower has height HT. Okay, so I can just give a name. So since this is given A, let me stick to this. PA is HT. Okay, now TV signal is actually transmitted by this antenna which is height. So this is the antenna which is height this on the earth surface. Now due to curvature of the earth, no direct signal is possible beyond this point B, because this is actually curved. So if you start from here, it will not directly reach to this point. Okay, actually this is the limit. This is the limit because of earth curvature. This is the limit from where if you emit the signal directly can reach here. Okay, so these B, C points are actually the limits. Okay, so now this, suppose this uh, this particular curve I can just take as, let me take as, because this is a huge arc, I have taken this BP, and this is PC as a straight line, and let me take this as distance D. P2 this B and P2 this C. So the point C and B, from where if you transmit the signal, it can directly reach to the antenna to this point A. So those, okay, I'm sorry, these distance are D already. So these distance are D. BA, I'm sorry, this is BA and CA. This distance are D. Okay. All right. Now, what we'll do? We'll take. See, this is 90 degree. As you can see, this is 90 degree. I can just consider this. This is a triangle. See, I'll write the right angle triangle. Right angle triangle. Right angle triangle. O, A, and C. So from here, what we can write, this figure. See, this is inside the earth. This is the center of the earth. So this is radius r, and this is also, and we are just considering earth as a spherical, like as a spherical object. So it has radius everywhere. Like this will be everywhere. From the center is r. This point B is also r. See, this is also r distance away from the center, and even P also is r distance away from the center. Okay. So OAC, I have taken O, A, and C, this right angle triangle. So you can see I can write the hypotenuse square, that is OA square, is equal to hypotenuse square is equal to this OC square plus CA square. So what is this OA? We can just find out what is OA. Excuse me. So this is nothing but R plus HT. I am taking HT. This PA is HT, and this OP up to that, this is R. So this is R plus HT. Okay. Now what is this? This OC is R, and this uh, A and C. This already we know. This we have taken as D. Okay, that is the D. So if I write here, OC square will be R square, and CA, that is D square, and this side is R plus HT whole square. Now if we simplify and find out the D means that range, okay? So this is the distance from which if you transmit a signal, it can reach directly. That distance I am calculating now. Okay, so that distance, it will be easily found out from here, that this is R square anyway will cancel out. So you'll get 2R HT plus HT square. So HT square, okay? So now if we take, okay, let me clean this portion little bit. So by now you know what we are doing. We are just taking the right angle triangle OSC, and from there we are just using Pythagoras rule to find out this D, the distance, like up to which distance you can have a direct communication through space wave. Okay, so then it will be D square. Let it be D square. So if I just take 2 2HT and R common, you will get 1 plus HT by R. Okay. Now look, this R is much greater than, because this is the height of the tower and this R is the radius of the R. So this HT, height of the tower, is much less than R. So this factor you can neglect. So uh, d, d square will be this nearly equal to this. After approximation you will get d square is equal to this, and hence we can find out that d will be root over 2r and ht. So this is the height of the tower, this is the radius of the earth. Okay, so the distance, this is the distance, so this is the distance up to which a TV signal can directly reach or directly received by another tower which is having a height ht. Okay, so we have derived this, that if the height of the tower, transmitting tower, sorry, receiving tower is this ht, then what is the maximum distance from which you can do direct communication? Now look, this is the range. Now we can find out the maximum range of space wave propagation between two antennas on the earth surface. So a space wave travels in a straight line from transmitting antenna to the receiving antenna. So I have taken two antenna here over this figure. You can see there are two antennas. So this is actually the transmitting antenna and this is the receiving antenna. Okay, now line of sight communication, we have to see the line of sight communication. So this is the line of sight, you can see that this is the line of sight, this dash line is the line of sight, right? So it is in short, it is called LOS, line of sight. So due to curvature of the earth surface, the direct space wave get blocked at some point. Thus the earth presents a horizon to space wave propagation, commonly called radio horizon. There is, so you can see, since it is a curve, as I was discussing in the previous topic, that since it is curved, if you suppose you have So you have curvature here. So if you have a transmitting antenna over here and receiving antenna here, you may not get line of sight, direct line of sight, isn't it? So you have, suppose this is the antenna and this is receiving antenna, this is transmitting antenna. At this distance, up to this distance, you can actually have a direct, that means LOS, line of sight communication. You can line of sight communication you can have. Okay. So therefore it is actually, so this space, for the space wave, the earth surface giving a horizon, like say, so below the horizon we cannot see the sun, right, and above the horizon we can see the sun. Similar to that, this earth surface, curvature of the earth surface gives this space wave a radio horizon. Radio horizon, below which, horizon below which there cannot be space wave or line of sight communication. Okay. So this, suppose this is the horizon. Now this path is called, this direct path is called line of sight path. Okay. Direct path or line of sight path. Now we know already this distance, this, see, this distance will be d, which we have already calculated. This d we have already calculated, that is root over 2r and ht. Okay. Transmitting antenna, so height of the transmitting antenna. Line of sight radio horizon for a satellite, sorry, for a single antenna at sea level is given by 2 root over 2r and ht. Now the maximum line of sight distance, see, maximum line of sight distance is this one, maximum line of sight distance, this one, as you can see here from the figure. This is denoted by dm. dm means maximum line of sight distance. So what is that, you can find out. So dt here, dt, this is the actually the distance of horizon actually. Okay, distance of the transmitting tower from this uh, midpoint, you can say, or the receiving. So okay, anyway, so this dt is the radio horizon for transmitting antenna, and dr, there is something called dr also. So this side you can say dr, this is called dr, this is called radio horizon, for distance of radio horizon for receiving antenna. So dt and dr, there are two things, dt and dr. I'll write, let me write. So what is dt? Radio horizon for transmitting antenna, transmitting antenna. And then dm, what is dm? dm is called the maximum line of sight distance, maximum line of sight distance. Sight distance. What is dr? There is something called dr. This is radio horizon for receiving antenna, radio horizon for receiving antenna. Okay, so we have got the terms. Now we can find out a relationship uh, between all these to get the maximum line of sight distance. It is said that it will be dm is equal to dt plus dr. So we know how this horizon, distance of horizon was. Distance of horizon is calculated as this, right? Hd, kind of that. Okay, so h, suppose this is h, this is in general, h is the height of the tower or height of the antenna. So we can write here the 2 r is the radius of the earth, and then ht, height of the transmitting antenna, plus this is 2r h, sorry, 2r hr. Hr means height of the receiving antenna, height of receiving antenna. So this will give you the maximum distance of line of sight. Okay, so clearly, if the signal is to be received beyond horizon, then the height of the receiving antenna must be large enough so as to intercept the line of sight of waves directly. See, if suppose this you are below horizon, suppose, so you know your this has to be large enough, like your height has to be so big that such that you can see at least some, like, okay, I'll just explain this. Let me see, suppose I am beyond the horizon. This is the radio horizon for transmitting antenna. So suppose my transmitting antenna is now put here. So your line of sight will be like this, direct for direct communication, or direct, like this line of sight. Okay, so it will go like this. Sorry, I'm sorry. Let me, like this. Okay, it will be a straight line. So if you have a large antenna only, you can receive the signal. Okay, so if suppose the signal has to be received beyond the horizon, the height of the receiving antenna must be large enough so that there will be intercept, there will be a intercept with the line of sight. Okay, line of sight. Moreover, the power of the transmitted wave from a transmitter decreases linearly as the inverse square of the distance. That means, like the transmitted wave will lose its power as you go like much larger distance. And how it so power actually varies as 1 by distance square, like that. Okay, so signal becomes weaker with the increasing distance. Hence, the long range, okay, the range of TV transmission, actually, the previous one, ground wave transmission is suitable for radio transmission, okay, radio communication. For TV communication, television communication, or television transmission, the space wave is used. So hence, the range of TV transmission can be increased by increasing height of the transmitting and receiving antenna, and by using a repeater transmitting station. Repeater means in between there should be some antenna which will actually reflect, and like that will receive and increase the power of the signal, and then again it will be sent to the receiving antenna. So if I start sky wave now, it will be like I'll be exceeding the time. So what I'll do, this sky wave, I'll take another class along with numerical examples for this chapter. Okay, so sky wave will learn on Wednesday along with various numerical examples. Okay, so I'll stop it here for today. So before I end the meeting, I'll just recap what I have taught you today. So we have started with space wave communication, and there are three types of space wave communication: ground wave, then space wave, and sky wave. We have discussed ground wave communication, which is guided by the earth surface, and there is a limitation in the frequency range, like long range communication, etc. So it can be suitable for low frequency communication. And space wave, it is suitable for TV communication, but there is a limitations. There are radio horizons. Okay, so if we want to increase the range, then we have to use large tower, and also we have to use repeaters in between the transmitter and receiver. So sky wave we will discuss in the next class. So thank you for your patience. We'll stop here. Bye for today.